Hi, we're Team I Thought This Was 112, and this is a progress report for our natural language processing project, WikiParse. Our goal is to build a system that, given a Wikipedia article, can generate as well as answer questions relevant to the provided article. The input for our system will be a plain text file containing an article, and the output will be a number of generated questions and answers. The inputted article is pre-processed before being used by our systems. Pre-processing includes categorizing every line in the input text article into article title, section headers, relevant paragraph content, and irrelevant or ignored text. Afterwards, we split the article into paragraphs, sentences, and then tokens. The list of tokens are then passed through a part of speech tagger and a named entity recognizer. We are currently using Stanford's NLTK to help us tokenize and tag our text. For our question generation system, we have currently implemented a method to generate who questions. Using the list of entities and the part of speech tagged article that we generated during pre-processing, we identify all sentences with a person entity and a verb phrase following the entity. The existence of a verb phrase following the named entity indicates to us that this sentence can appropriately be made into a who question. We then strip any text before the entity, replace the entity with who, and replace the end of sentence marker with a question mark to generate the question. We currently generate only simple who questions that are recognized directly from the article text. In the near future, we plan to expand these questions with other types of recognized entities. Additionally, we plan to supplement our question generation strategy with a scoring metric that evaluates how effectively our answering system can answer our generated questions, thus allowing us to select the easiest to answer and hopefully most comprehensible questions. We would like to note here that we deviate from our initial plan in that we did not lemmatize our input, nor did we find all occurrences of target verbs, as we decided that neither of these processes were necessary for our system's architecture. For our question-answer system, we also decided to deviate from the initial plan and find answers primarily through vector representations. So far, we have used a feed-forward neural net language model available on TensorFlow Hub to represent our question as well as each sentence in the article as 128-dimensional vectors. We then traverse through the sentences and repeatedly find the distance between the sentence vector and question vector by subtracting the two vectors and then summing the magnitudes of the differences. We then return the sentence with the shortest distance. In the near future, we plan to account for sentence length in vector representations of sentences for better retrieval of similar sentences that are of different lengths.